that is relevant, of course. And so please enjoy. Be up in a second.
One of the most important concepts of computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art of the language is in defining your own new words like these books. We do this all the time in sports. For example, in basketball, you start by learning how to dribble, how to do a layup, how to rebound. Once you've learned these really basic moves, you learn new moves, put together with the building blocks, like a hidden ball or a hidden run. And you can then go from there to do more complex plays. And once you learn that play and give it a name, everybody on the team knows how to do it.
All right, so this is a mediocre analogy for the situation, and it's going to be confusing because the excellent analogy that I'm about to give you after the video could easily be confused with what he's explaining. He's explaining a progress of learning skills, using those skills to do other more complex skills. That's not the case. Okay, we'll talk about a different sort of sports analogy for, well, but just that analogy is the one I will be critiquing or explain why it's wrong later. So just there's that. Okay, go.
Similarly, once you taught a computer how to do an action once using these sequence of commands, you can make up your own name for that action. So it's easy to repeat it later. When you define your own command and give it a name, that's called a function.
There are two steps to using functions in JavaScript. First, we need to define our function, and then we need to call it. When you define a new function, you are simply giving a single name to a set of actions you want the computer to perform. To call a function, you just type the name of the function, followed by parentheses. This is actually telling the computer to perform or execute the set of actions you gave a name to. You've already been calling functions when you use the turtle commands. The only difference is that someone else defined them for you. Notice in AppLab, the toolbox now has a tab called Functions. There are two blocks in there, one for defining a new function and one for calling a function. Let's make a function that moves the turtle forward twice. We'll call it Move Twice. Drag a new function block out and type in the name you want to give the function. Now, add the code that you want to run when the function is called. We'll add two move forward commands and then run our program. Hey, we defined a function, but nothing happened. The reason is we forgot step 2. We need to call the function. To call the function, we drag out the other block in the Functions tab and add in the name of our function. Now that we have both defined and called our function, the code will actually run and the turtle will move. Notice that if I also call the function before its definition, it still works. It just calls the function twice. Defining a function simply gives a name to a block of code without actually running it. The definition can actually be anywhere in your program. The rest of the code will execute line by line, just as before. Calling a function executes the lines of code inside the function, and afterwards, the program returns to where it left off when the function call was made. The fact that the function definition can be placed anywhere means that your code can get messy and really hard to read. So we typically put our function definitions at the end of our programs to help keep things organized. In JavaScript, we call them functions, but the generic term is procedure. All programming languages have a way to define and use new procedures, and it's just another example of how computer scientists use abstraction to solve problems. Once you've written a procedure or function that you know works as intended, you can call the function as often as you wish, without worrying about the details or problems you had to solve to get it working. And in defining a function to perform a certain task, you've essentially increased the capabilities of the programming language. It can now use that function on its own or as a part of even more complex actions. You can also see why it's important to give your function a meaningful and descriptive name. If you called it something like do stuff, it would be unclear what the function was supposed to do. and make it hard to use in your own code. By referencing a large and complex block of code by a single name, it makes it much easier to understand what a program is doing by reading the code, and also easier to locate and fix problems or errors.
All right, go ahead and load up code. We're going straight to lesson 5 of the current unit, bubble 3. And oh yeah, hold on a second. I locked it off for you for a second, and now it's taking too long. Just a second, folks. My mistake. Let's go like this. And go period 6. And all right, you should be able to hit refresh and it should be there. We're good. Okay. Bubble 5, excuse me, lesson 5, bubble 3. Okay, so here is what's up with functions. Functions are on the short list of maybe 4 or 5 major categories, topics of computer science, programming, foundational, standard, I don't know, other words. It is on the short list of major concepts. Okay, of 3 or 4, maybe 5 things. Variables, we haven't talked about any on the list, but other ones that you will hear at some point. Variables, arrays and objects, sort of conditionals and loops are going to be in every single program eventually that you write. Okay, so the analogy from the video about learning to dribble and shoot and pick and roll and that sort of thing isn't ideal, because it's not about reusing usefulness. I mean, it is kind of, but it can be confusing with learning, as opposed to the analogy I always use is a play in a playbook, sports playbook. You have to write the play, draw it up or whatever, and you have to call it. Once it's written up, you can call it as many times as you want. Okay, it needs both things. All right, so a couple of other tips for App Lab. I may have brought this up last time, I can't remember. Do yourself a favor and use full screen. You only have so many pixels. Don't limit yourself to a little keyhole amount of code space where you're looking at hundreds of lines of code 8 at a time. Maybe not hundreds, but 100 line. Okay. The other thing is they don't give you, like, this block right here is not available from at any point from the toolbox, even when we have like 6 or 8 different categories and 100 different blocks, all different colors, they never let you drag and drop out a single piece of what we call white space. In programming, just means blank lines. This can make the world of difference in terms of organizing. The way you get it is by going to text, going to show text, and just give yourself some blank lines, and then back to blocks. And then you can drag around these blocks just like anything. Now, it won't work. It won't give you white space if you just add lines to the ends. Like if you just add blank to the end of your program, it doesn't count that as white space. You need to put something down there. What you can put down there is a comment, which you do have a comment block, and you can make your own comments. I'm pretty sure I showed you before, in text and in JavaScript anywhere. You can do // and it will make a comment, which allows you to write notes to yourself or to someone else. Okay. The other thing you can do is if you want to deactivate part of your code to debug, you can put // at the beginning and it will deactivate that line instead of deleting it. If you need to check if something's working, you can comment out is the term. You can also use Control/ to do that, but only in text. Okay, so now that we have these useful tips, let's talk about functions. The key to a good function is something that you're going to reuse a lot. Similar to when we did the text compression, and you needed to come up with library entries. The more you reused it, the better entry it was. Okay, the more, but in this case, you are not picking out what text, or in this case, lines of code that are used the most. It's about creating the most useful tool so that you don't have to worry about it. Okay, and so first, we want to create a function called turnaround. We need to both define it, which this is a definition block. We're defining it, and we need to call it eventually. Let's get to defining it first. Okay, first thing, let's name it. Well, they literally want it to be called turnaround. For naming things in JavaScript, AppLab does let you get away with a few things that JavaScript does not, that true JavaScript does not, just to simplify things. But it doesn't let you get away with everything, and you might as well use the appropriate standards. When you're naming things, when you're naming functions, when you're naming variables, when you're using your own words to describe things, it benefits you to use words that are meaningful and descriptive. Like they explained in the video, do stuff is not a good name for a function. Draw a rectangle is a good name, if that's what it does. Obviously, if it didn't, that would be confusing. That is a suggestion, a good piece of advice. You are not allowed, the program will not let you start a function with, or start the name of a function with a number or a capital letter. You can have no spaces in the word, and you can have no symbols in the word. You can have capital letters throughout, except at the beginning. You can use numerals throughout, except at the beginning. A common tactic is to use what's called camel case. You may have already used camel case in your life without knowing what it was called. It is starting each new word with a capital letter instead of a space. It allows you to more easily read multiple words without spaces, where that's a little more difficult for your eyes to parse. So camel case is the capitalization standard of the day. There's another one that we never use called Pascal case, which is like camel case, except it starts with a capital letter, and now you know something that's completely useless. Okay, camel case, on the other hand, is useful, and it's a standard in programming to use to write multiple words capitalizing without spaces when you're not allowed to use spaces, like in naming a variable or a function, to write it like that. Okay, so we want to create a function that we can use that does this. It needs to do left, left, and forward. So we're going to throw a left, and a forward in there. So that is our function definition. And then we need to call that function, which you can just copy and paste, not that hard. I'm going to do my best to use the word to talk about naming a function instead of calling it, even though we would colloquially use call, like, what are we going to call this function? Turn around. No, we're going to name it turn around. And when we want to use it, we will call it. We will invoke it. Evoke? No, invoke. We will summon it. Okay. So turn around makes the cursor go left, left, forward. Well, which when it's turned around will be down. Okay, and now I think that's all we have to do for this one. Okay, if you don't have the white space, that's fine. It will still work. If you have the function definition above the function call, that's fine also. I will always be showing things with the definitions lower, because as they get more complex, they obviously are going to be longer and get in the way. But once you solve a function for what you want it to do, you really never need to look at it again. All you need to worry about is when you call it, and how many times you call it and in what order. But the tool exists. You can just, get it out of the way. You don't even need to, well, not let me, oh, because it's running. Is it really? Did I break everything? Error saving project. Oh, I broke it. All right. But either way, hit finish when you're done. Once it runs, hold on. I may have broken the internet. Give me a second here. When you do this, for a lot of these puzzles or bubbles, App Lab will actually check for okay, so yeah. So on some of these bubbles, App Lab is actually checking, or code is actually checking for some criteria of success. And it's not like in other bubbles where you can just hit continue and it accepts it as done. Be sure to hit run and then finish, and it will let you know if you did it right, at least to some standard. Okie dokie. So let's take a look at this. So we get a function called turnaround. Is this what you guys get when you got here? Just left inside the definition? Okay. Okay, so get some more practice calling the function turnaround along with your old friend to create a plus sign, turtle's first position. Okay, so we need to go, you can solve this several different ways. They essentially are trying to have you solve this in an inefficient way. So if we want to recreate this, first of all, let's I'm going to create some white space here just so that I can at least separate the definitions from the calls. Okay, so if I want to create this, and I'm running out of pixels, this shape, I need to move forward. Then I need to call our turnaround function. Okay, and that'll get me to here. Then I need to move forward again. That'll get me back to there. Then I need to do this again. That'll get me the bottom half. Okay, good. Then I can do a turn left. That'll face me that way. And then I just need the move forward, do that again, which will get me to there. Should face due east when I'm done. Okay, and then I just need another move forward, turn around, move forward. Okay, and then a triple left will get me back pointing up since we don't have right yet. Okay, so this is a way to solve this. It is not the best way to solve this. The best way to solve this is to break this, our intended shape, up into smaller repeatable portions. Okay, the smallest repeatable portion is a forward, a turnaround, and a left. If we could figure out a way to do that 4 times, we can save ourselves a lot of code. Okay, so we have forward, turn around, move forward, gets us back to here. Let's call that another function. Let's call this one draw arm. Okay, and we'll put everything in here, in there. Draw arm, for lack of a better word. And so we can just call draw arm and it will do the same thing. Nothing will have changed. Okay, and I can do what I did before, which was draw arm, which will give me here. Then I still have a left, draw arm twice, which will get me back to There, we're already doing better, and then a triple left. Okay, this is what I would call good, but we can do this even better. We can save this hassle of lefts each time by having each time we draw the arm, it ends with a left. Let's get rid of this. If each time we draw the arm, it ends with the left, it's set up ready to draw the next arm. So we can then call this, that'll be two of them, ready to draw the third one. That's the easiest way to do this. Copy. And three of them will be ready to draw the fourth. And then we can even speed it up a little bit. There we go. And simplified as much as possible to draw all four sides with everything looking nice and clean. Okay, we'll talk about it in a second, but this concept of this function draw arm uses the function turn around. Okay? This is an example of abstraction. We talked about abstraction with regards to the internet, with the HTTP, HTML thing using IP and using internet addresses and packets, and the packets using binary and the actual wires. Okay. Here we have a function draw arm that uses a lower level function called turn around so that it doesn't need to call turn left twice. Now, this isn't what I'd call an amazingly efficient or a huge improvement, because this one line is only replacing these two lines. So it's not actually making the program shorter. It is sort of, if we were making something much more complex, it would be more useful. So there's that. I think that's enough for this one. So bubble 5. And hopefully I didn't ruin everything. Okay. So as you know, we turn left. Okay, once we define function called right, use this function. Okay, so we need to draw a rectangle that is 2 units of forward tall and 1 unit of forward to wide. But in order to do that, we need to make a lower level function called turn right, or excuse me, right. It won't let you call it turn right because there already exists a function called turn right as a turtle one that is not accessible to you right now, and it won't work correctly if you do. So we'll just call this function right. That's also what they're checking for. And let's get a little bit of white space for our troubles. Okay, and so now we're just going to draw the rectangle using right for our turns, for our right turn. So move forward, and then we can call right. That should get us pretty far, like just up and over. Okay, and then another one is just going to be move forward and right. And then I just need this all over again. Boom. Okay, super easy. Okay, so we'll finish. And if we're going quickly, don't worry. We'll come back to it at the end, and I will post this replay when it's done. Okay, abstraction and simplified representation of something more complex. Okay, here is coincidentally the DC Metro map. I guess it could have been any metro. They chose ours. Fantastic. And it's simplified. You don't have to worry about all the details in this in terms of conveying the geographic information, the location of the different stops. You don't have to worry about cross streets or any of the other information that isn't relevant. Here, we're talking about simplifying things in terms of solving one problem and not having to worry about it after that. Okay, we use the analogy, don't worry, what's happening under the hood. You don't need to worry about what your car is doing with regards to gear ratios and hydraulics and fuel flow and that sort of thing. It's been solved for you so that you can just use, gas, brake, and turning, and the whole thing works. Okay, so this is a major concept and it will be discussed on the AP exam, but when we get closer to that, we will spend more time on that. Okay, so is this the one from the last one? I believe it is. Okay, so I think however you functions call, okay, so we talked about functions calling other functions back with the draw cross or draw arm. So this whole thing right here, let's get rid of some of this. This whole thing right here is what drew the rectangle using the turn right or right thing. Let's put this entire thing in its own definition, which we can, and you could just highlight or drag and drop each individual one, or switch to text and copy and paste it. That's not that hard. And we've defined it, and let's call it, let's name it. Let's assign it the word draw rectangle. And let us invoke it. And it should work the same. Fantastic. Okay, not much has changed. If you solved bubble 5, you just have to wrap your bubble 5 solution in its own function definition and then call it. Okie dokie. Bubbles 8, 9, and 10 are all a step-by-step solution process for drawing this somewhat complex shape that we are calling a diamond. The process we are using, this version of abstraction, is going to be bottom-up abstraction. The counter type, of course, would be top-down. But for bottom-up, we are going to solve the smallest problem first, then use that solution to solve the next smallest problem, and use that solution to solve the next smallest problem. Here, we are already given the turn right or right function, so we can use that liberally as we like. And our first issue is creating a function that does this. Okay, this series of commands will become a function that we can use to make a single step. That's why it's called draw step, and called many times throughout the our final program that will hopefully draw the diamond. So draw step is we are just recreating this forward, left, forward, and then right, which in order to do right, we need to call the function that's given to us. And to test it, let's call it. I think we do actually have to call it to get out of this. So we can call it. And there you go. It does one. Excellent. Okay, so finish and bubble 9. We can do the next stage, where we can use that single step to create a function that draws an entire side. Okay, So let's get a function definition. And we'll call it, actually, let's put it right above this and I'll keep them separated. There we go. Okay, so this function is going to be draw side. And draw side is going to call draw step 3 times. 1, 2, 3. Okay, and that will get us to there. Oh, wait, I haven't invoked the function. There we go. Okay, and you can see here, there is an extra little tail on the side that theoretically could be its own function, but it's only 2 moves. It's a forward and a right, and it will leave the cursor ready to call draw side again, because draw side assumes that the cursor is pointing in the direction you want to draw the side. So the second side, which goes this way, cursor needs to start pointing due east in order for it to work. So we're going to put at the end of our 3 draw steps, we need a move forward and a right. And when we run it now, it gets us to there. Excellent. Well done, everybody. And the last step is to set up a new function called draw diamond. And draw diamond is just going to be draw side 4 times. And instead of wow, it won't let me. You can't copy and paste. Weird. Apparently I'm pushing AppLab to its limits. Let's see here. Can I? Okay. So instead of calling draw side, we are just going to call draw diamond. And if we call draw diamond once, it will call draw side 4 times. Each of those 4 times we call draw side, it will go down and call draw step 3 times, which draw step will, and so on. Okay, so let's go medium slow. And you can see how it's going to go to there. And then to there. And well, just trust me on this one. I can watch the whole thing. And there you go. Okay, so this is our first or best, whatever, example of abstraction with functions using other functions, which in this case, use even other functions. We would call this function a high-level function and these 2 low-level functions. And it's sort of a coincidence that they are in the program code in the order of lowest level being lower on the code. It doesn't change the way anything works. Where you put things in the code, you can even put the function calls down at the bottom. But at this point, it is mostly about organizing things for your own benefit and doing it in a logical way, which to me, I think putting the high level functions higher up makes more sense. And so there you go. And let's take a look at the checks for understanding, make sure they are reasonable. Let's go like this, and we'll go boom, boom, boom. Okay, so 4 checks for understanding. First 2 are multiple choice or choose multiple. Okay, choose 2 statements that are true about functions, meaningful and functional, meaningful function names. Help people understand. Oh, I'm not going to read them all. It's what we just talked about. Okay, which is not true about functions. Okay, in your own words, explain at least one reason why programming languages have functions. Essentially, tell us you understand why we are doing what we're doing. And finally, okay, if you were trying to make this shape, okay, describe each of the functions that you would create. Okay, you do not need to write out the entire program code. Okay, essentially, how we solve this, how we solve the draw diamond with draw step, draw side, draw diamond. You can solve that or use the same sort of degree of specificity for this shape. Essentially break it up into smaller shapes or smaller portions. Okay, so we'll end it there and get it done.